In the last video, we wrote out our first smart contract. We now get to do the fun part, which is to tear this thing apart and understand every last line of code inside of here. So I took all this code, I put it into a diagram, and I labeled a lot of the different lines with some different notes. So we're going to go through this diagram right here and talk about every line of code. We'll first start off at line 1, where we had that pragma, solidity, and then some series of numbers right here. This specifies the version of solidity that we are writing inside this file. When this contents right here, when this code right here is fed into the solidity compiler, the compiler will look for this version right here. And then the compiler will customize the way it behaves based on that version. This is done to ensure that if solidity ever goes some change in the language, like if some new feature or some new piece of syntax is introduced, all the previous contracts that we wrote with previous versions of solidity are not going to suddenly break because they have older forms of syntax. Instead, the compiler will look at this version and say, oh, they're using a version from maybe 2 years ago. I'm going to make sure I don't try to use XYZ feature when I'm compiling this contract. So you can think of this pragma mark at the top right here as essentially being a version identifier to make sure we don't accidentally run the compiler in an inappropriate fashion. Down on line 3, we then make our first contract definition. And that's where we said contract inbox. The word contract is a key word, and you can think of this as being almost identical to whenever we define a class in Java, JavaScript, Ruby, Python. You get the idea. Remember, all these contracts that you and I are writing can really be thought of as being classes. And when we deploy these contracts to an Ethereum network, those deployed versions can be thought of as instances. So right now, we are essentially working on a class. And even if you look at the contract that you and I are writing right now, it really has the kind of definition or the structure of what looks like a class anyways. So the contract right here, that's the keyword that defines or tells the compiler that we are about to write a new contract. Right after that, we place the name of the contract that we're about to create. So you and I just made a contract named inbox. Directly underneath that line and inside this first set of curly braces right here, we defined a storage variable. You can think of this storage variable as being sort of like an instance variable. This is an instance variable that's going to exist for the life of the contract. When we define that variable, we use a couple of keywords here. So first is the word string. String is defining the type of variable that we're going to make. So we're saying that the variable message is only ever going to contain a string. So it will not contain a number, an array, or any other type of data. It's only ever going to contain a string. In a little bit, I'll tell you about all the other different types that we have available inside of Solidity. The next word that you see right here is public, and that specifies who has access to look at the contents of that variable. We'll talk more about the public keyword in just a minute when we start talking about functions. Finally, at the end of the line, we set the name of the variable. So we're saying that this variable should be called message. Now you will note when I said that we are declaring a storage variable right here, a storage variable is one that will be automatically stored with the contract on the blockchain. So that means whenever we change the value of message right here, the value that we assign to message will be automatically stored for all eternity on the Ethereum blockchain. And we can always pull our contract back up from the blockchain and look at the value of this variable right here. This is in contrast to local variables. Local variables are kind of one-time created when a contract is executed and then thrown away at the very end, and they are never actually persisted on the blockchain. In this course, for the most part, we will be making use of storage variables, but in some cases, we'll be using local variables instead, and I'll be sure to always point out the difference between the two. After that variable declaration up here, we then list out 3 different functions. So these are 3 different functions that will be a part of this contract. I want to point out in particular the first function. We said function inbox, and inbox was spelled with a capital I. Notice that inbox has the exact same spelling and capitalization as the contract name. Because the function has the same name as the contract, this function is regarded as being a constructor function. Constructor functions are automatically called one time when a contract is first created. So you can think of this first function right here as being invoked automatically when we deploy our contract to the blockchain. The other two functions inside this file do not have the same name as the contract. And so instead, these are functions that we can call on the contract after it has been deployed to the blockchain. Now, functions are pretty interesting, so we're going to pause right here and then break down these different functions and talk about the syntax for each of them. So quick break, and I'll see you in a minute.